Hello friends, we are now going to describe the stack as a linked list, and this stack as a linked list continued part, that is the pop operation. We have seen the push operation in a previous video, and now we are going to discuss the pop operation where the stack is being used as a linked list. So for that we will definitely write these two data structures, that is type def struct stack element for each node of the stack. Suppose this is a stack implemented as a linked list. Suppose this is linked to this is linked to this is the topmost node, this is a value 5, this is a value 10, this is a value 15. Suppose this is 505, this is 605, this is 705, this is 605, this is 705, and this is pointing to null. So this is a null pointer. So in this way you can imagine the stack to be a linked list. For that we have defined two structures. For individual elements we have declared this structure, and for entire stack representation we have declared this structure. So now we are going to write the pop operation. So pop operation can be a successful operation as well as a failure operation, because if the stack were empty, if the stack would have been empty, then there would nothing be there to delete or to pop from the stack. So in that case we are going to encounter a failure operation. In that case we are going to return 0, and we are going to return 1 for a successful operation if there is at least one node in the stack. So in that case we have to write the function in a way so as to return some integer value from the function, so that we can return the 1 or 0 as the case may be. So we are going to write the function code now. So let me write this int. Suppose this is the return type int, name of the function is pop. We'll take like this int star a, that is whatever is the value in the deleted or popped node from the stack is to be kept in that pointer variables int star a, and we have to take a stack pointer stack star s. Now we'll write like this: stack element star t. What we have taken? This sort of pointer, that is a pointer t, which is nothing but a pointer to a stack element data structure, that is this data structure. So stack element start t. If now we'll check if s arrow top is equal to null, that is if s arrow top equals null. So what is that case? If s arrow top is null, then what is this? What does this signify? That there is no top in the stack and there is no element in the stack, which is to be concluded from that. So the empty condition of stack is to be tested by seeing this condition, whether this s top is equal to null. We have to put the check in that way. So we will write if s arrow top equals null, then we'll write printf empty stack. We'll give a message empty stack. Then we'll have nothing to return to nothing to be put into this pointer variable a. So we'll write a is equal to null, and we'll just return 0, because this is a failure operation, return 0. Now if this is not the case, that is if the case would have been like this, where there are 3 nodes in the stack, where there can be 2 nodes in the stack, where there can be 100 nodes in the stack, where there can be 1 node in the stack at least, then in that case we will be able to perform the pop operation, because there will be at least 1 node in that particular situation. For that general purpose situation, we are going to write the remaining part of the code. Let me write that part and explain it to you. Now I will write like this, star A, what is to be popped? See this is the top, and this 5 is to be kept in star A. So what we'll write? Star A is equal to S arrow top arrow data. S arrow top means 505 and 505 arrow data means this 5. So we'll write like this, star A is equal to S arrow top arrow data. So what does that mean? S arrow top means, see this S arrow top means 505. It's 505. And 505 arrow data means this part. 505 next means this 605. So 505 contains two parts, this data part 5 and the address part 605. So 505 arrow data means 505 arrow data means 5. So we are just going to write like this, S arrow top arrow data, that is 505 arrow data, that is nothing but 5 in this case. So star A is being assigned to a value of, rather S arrow top arrow data is being assigned to a pointer variable A in the form of this code, that is star A is equal to S arrow top arrow data, and the content of this part, this right hand side part, will be stored in the value part of the pointer variable A. So if you want to print that value 5, you can just print this star A by a printf statement. So we have stored this 5 over here, and now what we are going to do, we are going to pop. We are going to do the pop operation. So pop operation always takes place from the top, as well as we have seen in the case of the push operation, which also takes place from the top. So anything which is to be noted, which is to be added or pushed into the stack is to be pushed from the top, and anything which is to be taken away from the stack, that is retrieved from the stack, is to be popped, which is to be popped from the stack is to be taken from the top as well. So in this case, we are going to take this node out of the stack, and in that case, top will now come to point the lower node. So what will be the pointer changes in that case? So let's write the pointer changes. Suppose we have taken a pointer T. Stack element start T at the beginning of this function definition. So we'll keep like this. We will keep T is equal to, we will keep the value of address of S arrow top, that is 505 in this pointer T by this code. T is equal to S arrow top. T is equal to S arrow top. That means T is equal to 505. Now what we'll do, X arrow top will be updated to point to 605. S arrow top will never remain over here now after the pop operation. So for the pop operation to be executed perfectly, we have to update the top value to point the top to this 605 memory location. What to write for that? S arrow top is equal to S arrow top arrow next. What is this? S arrow top is equal to S arrow top arrow next. S arrow top arrow next is nothing but 605. So it will contain 605. So this top never points to here. The top now points to this 605 memory location. So S arrow top is equal to S arrow top arrow next. Now this for freeing this original top position, that is 505, we have kept this address in the T pointer. So we will now write, just let me rub a little portion of this part and to create a space for writing that. So in order to free this node, we have to take this pointer to point to null. So what we will do, T next is equal to null. Then we will write free T and deallocate the memory and return the memory to the memory pool, and then operation is successful. That's why we will return 1, and put an end to this function definition by this closing brace. So if you have any doubts or queries relating to this section of code which we have explained, that is the POB operation in the stack as a linked list, that is the POB operation is, in the stack as a linked list, you can well post your doubts and queries into the comment section so that I can address them. Thanks for watching this video.